Hello everyone, and welcome. Today we're diving into a critical aspect of software engineering, building resilient database backup and recovery systems. In the fast-paced world of technology, data is paramount, and losing it can have catastrophic consequences for user trust and business operations. Think about the quiz platform we're building. It stores everything from user progress to AI model responses. Imagine if all that vanished overnight. This lesson isn't just about having backups, it's about designing a production-grade system that ensures quick, reliable recovery when disaster strikes. We'll explore the sophisticated strategies that even major tech companies use to protect their most valuable asset, data. By the end of this session, you'll be equipped to understand the nuances of different backup tiers, automate your backup scheduling, design point-in-time recovery systems, and apply backup validation and integrity checks. Let's get started. Why is this topic so crucial for any developer aiming to build robust systems? Consider the 2017 incident where a popular messaging platform lost 4 hours of messages. They had backups, but recovering took 3 days. The problem wasn't a lack of data copies, but the absence of effective orchestration and validation. This highlights a critical lesson. A backup is only as good as your ability to restore from it. For our AI quiz platform, losing user progress, AI model responses, or analytics data doesn't just mean a technical glitch, it means a breach of user trust that's incredibly difficult to rebuild. Naive backup approaches, like simply copying files, often create more problems than they solve, leading to corrupted backups, long recovery times, or even data loss in critical scenarios. Our goal today is to move beyond basic backups and build systems that can recover in minutes, not days, ensuring continuous service and user confidence. Understanding these real-world stakes helps us appreciate the engineering rigor required. To achieve true resilience, we adopt a multi-tier backup strategy, much like a major streaming service protects its viewing records. Our system operates on 3 distinct tiers, each designed for different recovery scenarios and RTO/RPO objectives. First, we have hot backups. Think of this as continuous streaming replication. It offers zero data loss for hardware failures because it's an instant mirror. However, it's vulnerable to logical corruption or accidental deletions, as those changes are mirrored too. Next, warm backups provide point-in-time snapshots, often hourly, combined with transaction log shipping. This is your go-to for most disaster scenarios like bad queries or schema changes. You can effectively travel back in time to any hour in the last week. Finally, cold backups are your nuclear option. Full database dumps stored across multiple, geographically dispersed regions. Even if an entire data center goes offline, your data survives. An intelligent orchestrator continuously monitors all 3 tiers, triggering automated failovers or alerts if inconsistencies or failures are detected. This layered approach ensures comprehensive data protection. Implementing a robust backup system goes beyond just having the tiers. It's about the patterns you employ. A progressive recovery strategy dictates that you always try the fastest recovery method first, hot backup, and only fall back to warm or cold if necessary. Each tier has different recovery time objectives, or RTO, and recovery point objectives, RPO, which define how much data you can afford to lose and how quickly you can recover. Critical to this is the backup validation pipeline. Every single backup must undergo automated validation, checking for schema integrity, data consistency, and even running query performance benchmarks. Invalid backups trigger immediate alerts and retry procedures, sometimes even using AI to detect corruption patterns. Finally, cross-region distribution is non-negotiable. Backups must be spread across at least 3 distinct availability zones with different disaster risk profiles. This protects against regional failures. This entire system integrates deeply with your database layer, AI services for model data, analytics engine for user behavior, and your monitoring stack, allowing for selective or full system recovery. To truly master production-grade recovery, there are a few success patterns you must embrace. First, automated testing. This means monthly disaster recovery drills using production backup data in isolated environments. Your teams need to practice full recovery procedures regularly to minimize stress during an actual incident. Think of it like fire drills for your data. Second, granular recovery. Instead of restoring entire databases, you should be able to recover specific tables or even time ranges. Users care about bug logs. This precision saves significant time and effort. And finally, zero downtime switches. When a hot standby is promoted to primary, it should happen without any service interruption. Users should continue taking quizzes invisibly while database switches occur in the background. Today we've covered how to understand multi-tier backup strategies, implement automated scheduling, design point-in-time recovery, and apply backup validation and integrity checks. By integrating these patterns, you can build systems that truly stand the test of time and disaster. Now, for a quick self-assessment, how would you explain the difference in use cases between hot and warm backups to a junior developer?